Hello, in the next two videos, we're going to be talking about the comparative advantages of case study methods. Now, a lot of misunderstandings have arisen from people who have been trained in quantitative methods, primarily frequentist statistics, and then they apply some of their methodological rules to case studies. And we'll see that leads to many misinterpretations of case study work. So in this next two videos, we're going to be contrasting qualitative and quantitative research methods. I'll talk about different theory development and theory building goals. I'll talk about the role of complexity in qualitative research, case study research, about the challenges of omitted variables, concepts and measures. We'll talk more about concepts and measures in some coming videos as well. We'll talk about the issue of generalization and then some other issues like indeterminacy, lack of independence of cases, and several other challenges. So different research methods have different comparative advantages. Formal models are very logical, mathematical even, but by themselves are not an empirical method of research. They have to be married up with either statistical or case study methods or some other empirical method. Statistics assess patterns in whole populations, but they don't necessarily get at causation. You've probably heard the phrase that correlation does not mean causation. And they also don't, although they could conceivably get at causation, but we're never quite certain. And they also don't explain individual case studies. They talk about averages for populations, but not individual level causal effects. Experiments can measure the effects of treatments if you have large randomized groups, and one is a treatment group and one is a control group. But even then, they don't give causal interpretations of individual cases. Even if there's a causal relationship that the experiment uncovers that operates on average for a population, it doesn't mean it operates for any individual case in the population. So it's a similar challenge as for statistical analysis of what we call observational data, data that was not organized as an experiment, but just observed from history or the world. Machine learning or artificial intelligence is great at pattern recognition, but it doesn't give causal models by itself. It doesn't explain how the software arrived at the pattern interpretations that it did. Case studies, great advantage is that they aim to get at causal inference and causal interpretation of individual cases. But conversely, they face challenges like how do we generalize from cases? Even if we have the right causal interpretation here, how do we know in what other kinds of cases or what other populations this will also hold true? So because all these different methods have different comparative advantages, there are advantages to combining methods so that the weaknesses of one are offset by the strengths of another. And we'll talk about that when we talk about multi-method research. Now, what I want to do is look at what case studies, in fact, are better at doing than others, other methods. I've given you some ideas about that already. I want to clear up some of the misunderstandings of case studies that have arisen from looking at them through the mindset of statistical analysis. We're going to talk about some of the limitations of case studies, and we're going to distinguish these limitations from instances where case studies are simply not done very well. In the future video on research design, I'll give 10 common flaws of case study research designs. These aren't necessarily all inherent flaws. They're just flaws that people, many of them arise when people do case studies not as well as they could do them. Okay, so I'm going to move to some discussions by Gary Gertz and Jim Mahoney about the differences between qualitative and quantitative research. The first argument they give is that they differ in their approach to explanation. I talked in our philosophy of science discussions about explanation and what it means. Here, case studies try to explain individual cases, show why the outcome was to have been expected given the context and the values of the variables. We call this a causes of effects approach. What were the causes of the outcome or the effects? Quantitative studies, sometimes they portray themselves as also doing that kind of causal inference, but often they're also looking just for the effects of causes. What on average is the effect in this population if it differs on this variable by this much? And this is very much the focus of the King, Cohen, and Verba book, is on the effects of causes. They also differ in their conceptions of causation. Case study methods are often associated with arguments about necessity or sufficiency, although not always. Some case study researchers think of themselves as dealing with probabilistic causes. And quantitative researchers typically often do think in terms of probabilistic causes, but again, some of them may think that they're really trying to get at causation that's actually more deterministic. They're just using statistical methods to do that. So I think here the difference isn't quite as stark as Mahoney and Gertz make it out to be, and I think if you surveyed researchers in these two traditions, you might get a range of answers about whether they think about causation being probabilistic or deterministic. A third difference is that qualitative researchers tend to think of variables acting in combinations and having different effects depending on the context. One way to talk about this is what we call I-ness causation. So let me just skip ahead to the next slide and explain what that is. I-ness is an acronym for insufficient but necessary parts of unnecessary but sufficient conditions. Insufficient but necessary parts of unnecessary but sufficient conditions. So that's a very complicated term. So let me break it out and explain it. Let's imagine that there's a variable A that by itself, it doesn't always cause the outcome Y. But whenever we see A together with B and C, then we get Y, right? So A is insufficient by itself. Let's imagine that when we see B and C without A, then we do not get Y. So A is insufficient by itself, but it's necessary for the combination A, B, C to produce Y. B and C without A do not produce Y, okay? Let's further imagine there are other combinations of variables that can cause Y, and they don't involve A or maybe even B and C. So maybe D, E, F also causes outcome Y, right? So that means the conjunction, the combination ABC is not necessary for Y, but again, ABC is sufficient for Y. Okay, so A is insufficient for Y. It's a necessary part of a conjunction of three variables, ABC, that causes Y, but that conjunction ABC is unnecessary for Y, but ABC is sufficient for Y because every time we get ABC, we get Y, right? So A is an I-ness variable, insufficient but necessary part of an unnecessary but sufficient condition. We'll see when we talk about typological theory, this is just one kind of complex relationship. We could also have SUIN, sufficient but unnecessary parts of insufficient but necessary conditions, and we can have other types of relationships as well. I'll explain SUIN when we get to typological theorizing. Okay, so that's just a long way of saying that case study researchers think of different combinations of variables and how they work together. Whereas quantitative researchers tend to think in terms of additive causation, they typically don't model what's called an interaction term. An interaction term is when you think the effect of one variable depends on the values of other variables. So let's take a simple example. If I asked you, does a road become more or less slippery for cars if the road has ice on it? If the road has sand on it. Well, let's imagine that the road has sand on it. If it's a dry road, then sand road might make a car slide a little bit if it tried to stop. But if the road had ice on it, then the sand helps to melt the ice a little bit. It gets stuck in the ice and provides some traction. So if there's ice, then sand is better for a car to have friction or traction on a roadway surface. So there's a simple interaction. The effect of sand depends on whether there's ice present or not, right? Qualitative researchers tend to think that in social life, there are lots of interaction effects. In fact, that there are what we call high-order interaction effects, where the effect of this variable depends not just on one other variable, but on the values of many other variables. In statistics, it's very hard to model anything more than a two-variable interaction effect, and even two-variable interaction effects are not often included in statistical models, and even when they are, they're often misinterpreted. Bear Braumiller has an article where he shows a lot of examples where interaction terms are, even if they're included, they're misinterpreted in statistical models. So this is a pretty significant difference in how qualitative researchers tend to think about complicated interaction effects, and quantitative researchers tend to neglect them. A fourth difference is what we call equifinality. Equifinality is a term for different paths to the same outcome. And we may have many different paths that may have very little in common. When I talked about Inus variables, I gave an example of, a combination ABC leads to Y, but there's this other combination DEF leads to Y. We could imagine a real world example. To get elected to office in a democracy, it may be sufficient to have a party that has a strong majority in the district, or it may be sufficient to have name recognition, lots of funding, and a good personal reputation. And those are two different paths to winning election in a district, and they may have little or nothing in common. In quantitative research, there tends to be very little discussion of equifinality or different paths or different combinations. Implicitly, if we do a regression analysis, there may be lots of different combinations in there that lead to the outcome of interest. But the focus is not on charting out the different kinds of combinations. The focus is on trying to estimate the average correlation or the average effects of each variable, so that if in principle, if I increase this variable by this much, how much would that change the outcome, right? That's what it tries to get at. On generalization, qualitative researchers tend to be cautious about generalizing from cases because we think that there's a lot of different paths, different combinations, different interaction effects, and what we call generally causal heterogeneity, lots of variance in causal relationships. Whereas quantitative researchers tend to try to make arguments about causal homogeneity, even though they know that's a very strong assumption that's not always justified, or what's sometimes called the unit homogeneity assumption, that this much change in this variable has the same effect across all the cases, even though we know often it doesn't. So statistical researchers, because they want to get a big sample size, tend to try to treat populations as being homogeneous. I'll come back to the issue of generalization somewhat later in this video, or the following video. Okay, so some other distinctions that Gertz and Mahoney point to: case selection practices. Case study researchers tend to start often with the positive cases, the cases that are positive on the independent variable of interest and positive on the outcome, right? So if we want to study, do arms races lead to war, we tend to look first to cases where there are arms races and wars and see if there's some relationship there. But we're also interested in the positive negative cases, arms races that did not result in wars. And we're also interested in the negative positive cases, no arms race, but there was a war anyway. And we tend not to be too interested in the 0-0 cases, no arms race, no war. That's most of history. And that won't be very informative on the relationship between arms races and wars. So we often choose cases knowing something in advance about the values of the independent and dependent variables. And we'll talk a lot more about case selection when we talk about research design. In statistical studies, there's a big focus on random selection because and you want a large number of cases that are randomly selected. So hopefully that eliminates the chance that there's some bias in the selection of the cases, and you want the cases to be representative of some population. But random selection is a terrible idea for case selection for case study work. You might end up randomly with a lot of 0-0 cases that really aren't very informative. So those are quite different ways of thinking about case selection. We'll come back to that when we talk about research design. For empirical observations and theory, in case study research, we tend to be interested in individual cases, and we're concerned even when there's one case that's an anomaly, one case that doesn't fit a theory, that sparks our curiosity, and we might want to study that case. We call that a deviant case or an outlier case. We also think some cases are substantively important. We want to study them, the big wars, the big economic crashes, and so on. In statistical research, every case is treated as kind of equal. So you might have a data set of, let's say, votes in the US Congress, and every vote gets counted as one unit in the data set, even though one vote may be the vote to start a military intervention in Iraq in 2003, and another vote is a purely symbolic vote to designate something Dog and Cat Month. Those are both counted as one point in the data set, and they're often treated as of equal importance in making causal inferences or inferences about correlations, much less causation. And there's not necessarily attention to substantively important cases. So this is another big difference between qualitative and quantitative research. As I mentioned earlier, when a case doesn't fit a theory, case study researchers tend to get curious about it. We get interested. We might want to study that case closely. In statistical research, there's kind of a default assumption that cases that don't fit a theory or cases that have a large error term are just going to happen every so often. You have a lot of variables that have tiny effects that you might not have included those variables in your model, and so you expect every so often there will be a case that really doesn't fit the theory, and they're not too curious about that. But a case study researcher would argue that in not studying those cases that don't fit, statistical researchers might be missing an opportunity to understand some mechanisms or some theories that they hadn't explored before. And they may also, if those cases that don't fit are actually changing the statistical results or pulling the regression line toward themselves, they may be making a bad inference if they're making claims about a population when really those claims depend largely on the cases that don't fit. The nature of those claims don't fit the theory very well. Fit the particular cases very well. On concepts and measurement, we tend to spend a lot of time on that. In case studies, we'll spend a couple sessions talking about that, a couple videos down the road talking about that. We tend to focus on nominal measurement, named categories, democracies, non-democracies, and so on. Sometimes we'll have ordinal measurement, high, medium, low. Sometimes we might have interval measurement with even more gradations. But in quantitative work, they typically want to get fine quantitative gradations of measurement, ideally interval or maybe ordinal, and they tend not to deal with nominal variables so much, although they sometimes do that. So their challenge is to measure lots of cases, sort of roughly. We tend to measure a few cases and try to measure them as precisely as we can. Okay, so those are some differences that Gary Gertz and Jim Mahoney have identified. Another set of authors that have tried to think about differences between qualitative and quantitative work are Henry Brady, who comes from the quantitative side, and David Collier, who comes from the qualitative side. And in their writings, they've identified 4 distinctions. So one I've talked about a little bit already, which is the distinction on the level of measurement. So as I mentioned, qualitative is often nominal, sometimes ordinal. It could be interval, whereas quantitative work typically is interval or ordinal and sometimes nominal or named categories. Or they might use what's called a dummy variable for democracy, non-democracy, for example. The size of the N, or the number of the cases, typically in case study research, it's 1 to 4 cases. Sometimes it may be as many as 10 or even 20, but once you get to 10 or 20, it's usually a group research projects where different people are doing different cases. In statistical research, typically you want lots of cases. You could sort of start to do some statistics at around 30 cases, but that's pretty weak or underpowered statistics. You really want hundreds or even thousands of cases to really have strong statistical results. So this is a big difference between the two methods. Now, sometimes people will use that to argue, well, you only turn to qualitative or case study research when you only have a few cases and otherwise you do statistics. I don't think that's right. I mean, I think sometimes even if you have 1,000 cases, there are reasons that you might want to still do some case studies as well as some statistics. You might want to study those deviant or outlier cases. You might want to study particular cases just to see what the processes and mechanisms are, even if they're typical cases. So just because we have lots of cases, hundreds of thousands, it doesn't mean we wouldn't want to still do some case studies for some theory building and theory testing purposes. A third distinction is statistical tests. Obviously, statistical research uses statistical tests. Most case study research does not. But as we'll see in some later videos, we can use Bayesian statistical tests on case study evidence. Bayesianism is just a different approach. It's a different kind of statistical logic from frequentist statistics, which frequentist statistics are the approach to statistics that's taught most often in the social sciences in the United States, at least. But we'll see that these are very different logics, and there is, in fact, or could be argued to be, a Bayesian statistical logic that underlies case studies. Case studies typically do very thick analysis where we learn a lot about our cases. We do what's called soaking and poking. We immerse ourselves, sometimes inductively in the cases, just to learn everything we can about them. Whereas in statistical research, there's just a much thinner sort of measurement of the variables across many cases, but you don't have time to go into the details of each case and to try to adapt those measurements to the specific context of the case. So those are some pretty big differences. As I said, case studies use a Bayesian logic. I'll talk about that more down the road when we talk about Bayesian process tracing. But this is a fundamentally different logic from the logic of frequentist statistics, and a lot of the misinterpretations of case study methods come from people trained in frequentist statistics who then misapply that logic to case studies. This is part of my critique with Alex George, the critique against the King, Cohen, and Verba book, which tends to use a kind of a frequentist lens to view case study research, and we think that leads to some mistaken advice about case study research. Okay, let me stop there for this video. If you're taking a course with me, let me suggest that you take a few minutes to write down questions you have about this. You may have had courses in frequentist statistics. You may have more questions about the differences between how qualitative researchers think about case studies versus how statistical researchers think about cases. So take a few minutes and write down any of those questions on the Google Doc that I'll provide, and then you might take a break and move on to the next video.